Okay, my dear friends, last class it is continuation. This is reproducibility. So we are already number of times without varying of time the readings is coming. So the measurement is going to take readings. Those things were is called as reproducibility. By now we will see that some graphs over here, reproducibility. So in this reproducibility, see that pressure, again we are taken into pressure data. So that pressure data, this is we are going to taking see that 4 2 means minus 4 2 0 2 4 8 4 6 8. See that how much that pressure symbols will be there. Same readings will be there within the limit of 4 to 6 pressure bar. You can say that 4 bar and 6 bar. Over there same readings will be there repeating. So that is called as repeating without varying time. So there is no varying much of time will be there. Without over there the same thing will be producing, means measurement is going to be giving same readings. That's why it is called as reproducibility. So different measurement systems we are going to see. That is reproducibility we are denoted by capital R. Repeatability also we are going to same thing we are denoted by small r. Same measurement system and short time. Okay, so same thing will be there here. Okay, measurement value we are going to taking and true value we are going to taking. So in between that frequency will be that end over there, and again it is going to be showing that same thing will be there. So see the local, and in between local and frequency systematic error will be there. After that repeatability will be there, same repeatability will be there, same thing will be there. Small also repeatability, same thing will be there. Reproducibility also will be there. Both two things we are measured, sigma r and sigma capital R and sigma small r. Now we will see that drift. It is also one of the it is also one of the static characteristics. So what is here, drift is defined as the gradual shift in the indication over a period of time wherein the input variable does not change. So what is that? The gradual shift in the indication over their period of time. It should not be changed. Suppose period of time means some period you take 60 seconds. In the 60 seconds, in that input should not be changed. So that is called as a drift. Suppose given time is 60. So in 60 the given period is 60, that time there is no input variable. There is no input variable. Suppose we are going to we are drinking the water. Suppose example you take, given time is 60 seconds. In given 60 second time you are going to taking the water only for 1 liter. So that input variable is not going to change given period of time. That is called as drift. In that drift, it is caused because of environment factors generally, like stray electric fields, stray magnetic fields, thermal, EMF, electromagnetic force, changes in the temperature, mechanical vibrations, etc. So drift is also we are classified zero drift, span drift, or sensitivity drift, zonal drift. These are the classification of the drift. Next we will see that static error. What is the static error? One more static characteristics. So this is that it is the deviation from the true value of the measured variable. So deviation means difference. There will be a difference will be there. Measure value one thing will come, and true value will be there, another will be there. That is called as static error. Means measure value, suppose say that 600 rpm, say that true value is 1000 rpm. So that difference of the error means that error is called as static error. So it involves a comparison of unknown quantity and with accepted standard quality. So it is the degree and the instrument will be approached to the expected value and expressed in terms of error of measurements. So this is called as error. Suppose measured value is 600, true value is 1000. So that is the difference will be there, that is called as static error. This is called as static error. Next, another one is dead zone. What is that dead zone? Dead zone is nothing but changes of the input quantity for there is no output. So say that for best example I can say that dead zone. Suppose if you are going to preparing that final year examinations, and then you are reading, you are going to giving input, but there is no output. So that is called as dead zone. Same thing in instruments is also happening. We are going to measuring with the help of tachometer one electric motor. We are going to putting that input quantity will be there, but it is that measurement is not going to showing that output. So that there is no output, but input you are going to giving, that is called as dead zone. You please see clearly that this graph will be there, measured value, input value, dead value. So there is no means output. Next, precision. Precision we are going to using it very widely in manufacturing process also. Precision is the more important. So if the precision is not there, the whatever the job or workpiece we cannot use in machines. So it is that measure of reproducibility of the measurement that given the fixed value of variable. So we are going to giving one fixed value. Suppose 20 microns will be there. So 20 microns, same thing we have to reproduce it. Otherwise that is not called as precision. So precision measures the 1 degree is there, that is successive measurement. That is called as successive measurement. For example, you take one instrument, readings taken up to 1 by 100th of unit. The instrument can zero adjustment error is also will be there, whereas other readings instrument is highly precise. So we can say that the instrument has zero adjustment error, but readings are obtained by the precise. So that is called as precision. Thus when a set of readings is shown the precision, that results agreeing themselves, it is not essentials of that results are accurate. Essentials that results are accurate. Suppose you are going to giving 20 microns. 20 microns only reproducibility should be there. Otherwise is each and every. Then only we can say that instrument is having precision instrument. Precision instrument. See that by seeing of this vernier calipers is there, screw gauge is there, depth gauge will be there, okay, level micrometers will be there. All these things precision instruments. Suppose if you are going to measuring one ball diameter with the help of vernier calipers, so how can we measure it? So if you are going to measuring that one, that you have to show that. Suppose another instrument, so you should have to measure properly. That measurement will show that one measurement is going to showing that 25 mm. Another measurement also should show that 25 mm 0.1 or 25 mm accurately. Then that instrument is called as, the measuring instrument is called as precision instrument. Now we will see that threshold. One of the threshold is a very important characteristic of static. So threshold is that smallest measurable input. Below that which no output change can be identified. So there should not be any change. Input, how much input will be there, that much of output should be there. That is called threshold. That is called threshold. That is called as threshold. So that we can measure that one. So that is called as specifying the threshold, manufacturers give that first detectable output change. So how much input you are going to giving, that much of output should come. Input how much you are going to giving, same thing should give that output. That is called as threshold. Next, so linearity. Linearity we can define as the ability of an instrument to produce its instrument linearity. So linearity we can define at maximum deviation of the calibration points from the ideal state, ideal line. So we can define by mathematically this linearity, maximum deviation of output from the measurement by that actual readings. So what is that maximum deviation of the output? So say that deviation should be there, means delta x will be there. Suppose 10, 10.1, 10.2, 10.3, 10.4 will be there. So that is that deviations will come, but actual readings will be there only 10 or say that 9.9 or 9.8. So that this is that actual reading. Deviation readings will be there, it should be plus or minus. Suppose say that 10.1, 10.2, 10.3 or 9.7, 9.6 will be there. Deviation should be there. That deviation should not be there. That is called as linearity. Linearity of the instrument. Next one, we can see that linearity graph. See that here we can understand by seeing of this graphs. We can see that most of the instruments specified function over a particular range, and instruments can be said to be a linear when the instrumental changes in the input and output constant over the specified range. Okay, see that first what is that linearity? So the output deviation should be there, but whereas actual readings should be actual readings divided by that actual readings. See that one it will go straight, there is no deviation, linearity should be there. Another one, second graph will be there, there is a deviations are more, so that graph is there. So another third one, some of the part over there it is going to be showing that straight line, afterwards it is going to be curve, so deviations are more. First one, there is no deviations, deviations are there, slight deviations are. Three curves we can understand by this linearity. Thank you. Next slide, next video we will see that the remaining characteristics.